Hello, how are you? My name is Jose Manuel. Today I am going to explain a little about functions of several variables, what they are, and some numerical examples. In this section, we want to go over some of the basic ideas about functions of more than one variable. We next want to talk about the domains or functions of more than one variable. Recall that domains of functions of a single variable g is equal f to x consisted of all the values of x that we could plug into the function and get back a real number. Now, if we think about it, this means that the domain or a function of a single variable is an interval or intervals of values from the number line or one-dimensional space. The domain of function of two variables f is equal f to x g are region from two-dimensional space and consist of the coordinate pairs x to y that we call plug into the functions and get back a real number. First, remember that graphs or function of two variables f is equal f x y are surface in three-dimensional space. For example, here is the graph of f is equal to x2 plus 2x cubed minus 4. Graphing functions of two variables. Suppose we wish to graph the function f equal f to x to y. This function has two independent variables, x and y, and when dependent variable f. When graphing a function g is equal f to x of one variable, we use the Cartesian plan. We are able to graph any ordered pair x, y in the plane, and every point in the plane has an ordered pair x, y associated with it. Y the function of two variables, each ordered pair x, y in the domain of the function is mapped to a real number f. Therefore, the graph of the function f consists of ordered triples x, y, f. The graph of a function f is equal f x, y of the variables is carried surface. To understand more completely the concept of plotting a set on the ordered triples to obtain a surface in three-dimensional space, imagine the x-y coordinate system lying flat. Then every point in the domain of the function f has an unique safe value associated with if f is positive, The graphite point is located above the xy plane. If z is negative, the graphite point is located below the xy plane. The shape of a graphene point becomes the two-dimensional surface that is the graph of the function f.
Hello, my name is Roberto and let's save the following examples. Well, this equation will be elixir parabola. Gonna say c2 is equal to 0, which is gonna give me 3 minutes. Three minus x squared minus y squared. So which means the x and y. 3 is x squared plus a square equals 3. Um, this is circular with radius. And I'm gonna graphic this. So I'm gonna draw out the circles with the radius. But this gives stay forever. Um, so the dominion is gonna be all of 2. If you put in values for x and x, that's values below the xi plane. Now still takes on negative values. Thank you.
Is Lily. We have to account on serum igual a 6 igual a 2x menos 3y. 3, 3y equals 6 menos 2x. 3 y equals 6 entre 3 menos 2 entre 3. Yeah. Hello. Today we will explain exercise on variable function. Given the function f of x equal 3x minus 2, find f of 2 and f of minus 3. We copy the function f of x equal 3x minus 2. We replace the x equal to the rest of the function is the same. We solve the operation. First, f of 2 equals 6 minus 2 equal 4. First, we solve the multiplication and then the subtraction. We multiply 3 by 2 equal to 6 and subtract minus 2 as a fin result obtained 4. With the function is at number 2 and the x-axis. It means that the function passes from number 4 on the y-axis. With the function is the point with which the function passes is 2.4. Yeah. Next, we work with the negative number. F the x equals 3x minus 2. F of minus 3 equal 3 minus 3 minus 2. We longer the function and substitute the bxb minus 3. The minus 3 is placed in the parentheses minus 3. First of the functions goes down the same. We solve the operation 3 times minus 2 gives minus f of minus 3 equal minus 9 minus 2. F of minus 3 equal minus 11. One of the points from which the function passes is 3, 11.
Hi, I'm Emiliano, and I'm going to explain the topic domain for the multiple variable functions. Today I'm going to explain how to identify the domain of this function. G of x comma y equals. I'm going to do it again. G of x comma y equals the square root of 9 minus x squared minus y squared. The domains follow the same rule, algebraic rules. This is a rational function, and we have to look when that thing comes positive. We have to do an inequality. We have to put 9 minus x squared minus y squared, and we have to do when this comes positive, and the inequality goes something like this. We have to see when this comes positive, and it will be something like this. 9 more or equal than x squared plus y squared. This expression right here is, if we put it into an equation, we can see something like this: 9 equal x squared plus y squared, and this is a circumference equation. If we put a plane over here, we will see how our circumference forms. If you see, we have a radius equals 3. If we put the circumference, we will see something like this. And this is the graph of all the function. And with this, we can identify which is the domain of the function. This, if this will be true, we have a 3, and we have a minus 3 over here, a 3 over here, and a minus 3 over here. And the domain explained that is all the thing over here and not the thing over here, or over here. We have to identify the domain when equals goes over minus 3 and 3. Minus 3 and 3. And the minus 3 over here, and the minus 3 over here, and the plus 3 over there. The domain goes something like this: d of x comma y of x squared plus y squared. That will be something more small, minor or equal than 9. And with that, we could see our domain. We can see that the domain equals the values where this and this is minus than 9.